Good morning, everyone. This is Manuel J. Reyes, and now we will going to answer one of the problem that is given by our teacher, Serene Inson. So I choose this problem. The problem is an open field is bounded by a lake with a straight shoreline. A rectangular enclosure is to be constructed using 500 feet of fencing along three sides and the lake as a natural boundary on the fourth side. What dimensions will maximize the enclosed area? What is the maximum area? So this is the problem. First of all, we are going to draw an example of what is in the problem. First, we're going to draw a river. Let's put a river in this place. River. This is a river. Sorry for the bad drawing. As in the problem said that it will make a rectangular enclosure and is to be constructed using 500 feet. So we're going to put a rectangular enclosure. Rectangular enclosure. In the problem, it didn't tell where the 500 feet is being put. So let's just put a variable in these two sides. Let's just say we give a variable x in these two sides. Let's put here what is the given. 500 feet. 500 feet of fencing. Now, we use two x variables, so we're going to minus it in the 500 feet of fencing. So we're gonna put 2x. Use variable equals x plus x, then it will be equals to 2x. Okay, now let's put it here. The 500 minus 2x. Okay. After that, let's solve it. First, let's put here the maximize. Maximize. Okay. First, let's put the... First, we're going to... as it is a rectangular enclosure, we're gonna times length times width. So, it will be area of x is equals to length times width, then it will be x times 500 minus 2x. After that, we're going to put we're going to solve it. First, let's put area of x is equals to x times 500 is equals to 500x, and x times 2x is equals to negative 2x squared. 2x squared. Okay. Next is we're going to find the derivative of this problem. So now let's put the derivative in it. Derivative of a of x. Derivative of the area is equals to, here we're going to put 500 only. And here we're going to 2 times 2 it is equals to 4. And 2 minus 1 is equals to 1. So we're gonna just put 1x. Knowing that the derivative is defined, now we're going to set it into 0. So let's put here derivative of a equals to x equals 0. Now let's just put 500 minus 4x equals 0. Then after that, distribute it. 500 equals 4x. Now we divide both sides by 4, and it will give us x equals 1, 2, 5. So now let's justify if this is correct. Now we're just gonna draw like this, and let's put 125 here. After that, let's try if this is an increasing or decreasing in this type. Let's put here 0. Here. So we're going to find, or we're going to choose between 0 to 125 to know if this is a positive. Now, like I said, I'm gonna choose from 0 to 125. So I think I'm gonna use, let's say I'm gonna use 1. X equals to 1 in this derivative. So the the given is 500 minus 4x. So let's try this. 500 minus 4 times 1 equals 0. Oh, sorry, we don't put it there. So the answer will be this equals 496. So it will tell us that between 0 to, we can tell that this is positive. So it can tell us this, that between 0 to 125 this is going positive. Positive. It just tells us that from 0 to 125, if it gets bigger and bigger until 125. Now let's try more than 125. It became still increasing or decreasing. So let's say we 125 to 250. Let's say 250, because in this equation 2 times 250, it becomes 500. So 500 minus 500 becomes 0. So let's try 250. 250. It's 250 here. So let's say I'm gonna use x equals 200. Let's say 200. So in this, I'm gonna solve it like the other one. So let's put 500 minus 4 times 200. It will give us 800 minus 500. So it will become negative 300. It is negative, meaning it is decreasing. So after the 125 feet, it becomes decreasing. So we can tell that this is the maximum area, 125. So now let's look at the maximize enclosed area. Now, as we know, the maximum area, which is area as 125, we can now solve the maximum area. Now let's change the x into 125. So this is first. Let's write the given. X is equals to x times 500, because it is length times width. That's why x times 500 minus 2 x squared 2x. Now let's change the x into 125. So equals 125 times 500 minus 2 times 125. 125. Now let's solve what's inside the parentheses. 2 times 125 is 250. 250 minus 500 minus 250, it will give us 250 times 125. 125 times 250, it will give us the answer 31,250 feet. So this will conclude for this problem. So the maximum area will be, let's put there, will be 31,250 feet, square feet. Okay, that's all. Thank you for watching. Hope you understand this problem and how did I get the answer in this problem. Thank you very much. Bye.